guys, in this video we'll discuss about a few topics like quadratic forms. And here we go with quadratic form. A homogeneous expression of the second degree in any number of variables is called as quadratic form. So it is having the second degree and it can be any number of variables. If we see the example here, x square plus 2xy plus y square is a quadratic form. So it is highest degree is 2. So you can tell it is a quadratic form, and that is having the two variables. The two variables are x and y. And if we go with the second example, x square plus xy plus yz plus y square plus z square is a quadratic form in three variables. So here we can see the highest power degree is 2. Then it is a quadratic and it is in three variables, as you can see the three variables as x, y and z. So an expression of the quadratic form, q is equals to x power t, that is nothing but transpose of the matrix into a into x, and it gives a summation from I is equals to 1 to n, and the summation from j equals to 1 to n, and aij into xi into xj. So here aij nothing but constants, and is so this form is called as a quadratic form in n variables. So if you take the n as 3, then it comes with I equals to 1 to 3 and j equals to 1 to 3. It comes as here the 3 by 3 matrix. So the variables can be from x1 to xn. So if the constants aij are real numbers, it is called as real quadratic form. If they are imaginary, then we can call it as imaginary quadratic form. And where A be the symmetric matrix of the quadratic form. So here A is always a symmetric matrix. Here if you see the note, the matrix of the quadratic form will be of this form. As first we will have the coefficient of x square. If it is in three variables, then we get the 3 by 3 matrix. If it is in three variables like x, y and z, we get 3 by 3 matrix. If it is in two variables, we get it as 2 by 2 matrix. So if it is a 3 by 3 matrix, it means three variables are there. Then first element comes as coefficient of x square, and the second comes as coefficient of xy, and half of the coefficient of xy. So if we have the coefficient of x, if in equation we have it as 2xy, then half will be given at this place and another half will be given at this place. So 2 by 2, that comes as 1. Here we have to write only the coefficient of xy, and here next element comes as half of coefficient of xz, and similarly here half of coefficient of xy. So here you can see these two elements will be same. When we divide it by 2, it gets into equally half, and this element and this element will be same. Here you can see coefficient of xz by 2, and here these two elements will be same. So that's why A be the symmetric matrix of the quadratic form. So the matrix is always symmetric, and these elements are diagonal elements are nothing but this is a coefficient of x square, coefficient of y square and coefficient of z square. So for example, if you see one equation here, x square plus xy plus yz plus y square plus z square. Here you can see, for our convenience, to make our problem easy, we write here as x y z, and here x y z. So first element comes as x into x, that is x square. So coefficient of x square we will write here. Then x into y, then coefficient of xy divided by 2. Then x into z, that is xz, coefficient of xz divided by 2. And this element comes as y into x, nothing but x into y, both are same. So coefficient of x by xy by 2. So this element comes as same. And here y into y, nothing but y square, so coefficient of y square. Then y into z comes as yz, coefficient of yz divided by 2. Then here third row comes as z into x, nothing but xz, so coefficient of xz by 2. So here you can see this element and this element are similar. and next it comes as x into y, nothing but yx, z into y, nothing but yz, that is coefficient of yz divided by 2. So you can see these two elements are similar. Then it comes as coefficient of x z square as z into z, this is the coefficient of z square. So in this way the given equation we will write in the form of matrix, that is nothing but quadratic form. We see three problems. Find this symmetric matrix corresponding to the quadratic form x1 square plus 6x1 x2 plus x2 square. So if we expand this x1 square plus 6x1 x2 plus x2 square, this can be written as x1 square plus 3x1 x2 plus 3x1 x2 plus x2 square. It means this 6x1 x2 can be written as 3x1 x2 plus 3x1 x2. So I am dividing by 2. Then the matrix comes as I told you here, x and x1 and x and x1. Oh sorry, it's x1 x1 and x2 x2. x1 into x1 comes as x1 square. So coefficient of x1 square you should be written here, and x1 into x2. Similarly here x2 into x1, nothing but x1 into x2, and here x2 into x2, x2 square. So the coefficient of x1 square should be written here, and the coefficient of x1 square is 1. And next coefficient of x1 x2, that is, what is the coefficient of x1 x2, that is here 6. So 6 here it is divided by 2, and here is also divided by 2. So here the total coefficient we are dividing it by 2, then we will get it as 3x1 x2 and 3x1 x2. So here x2 into x1, nothing but x1 x2, that is divided by 2. Here x1 x2 coefficient is 6 and divided by 2, and here x2 into x2 is x2 square, the coefficient of x2 square is 1. So here we get it as 1, 6 divided by 2 is 3, and here 3, 1. So this is the overall symmetric matrix. So this is a symmetric matrix for the quadratic form x1 square plus 6x1 x2 plus x2 square. So if we go with another question, find the symmetric matrix corresponding to the quadratic form x1 square plus 2x2 square plus 4x2 x3 plus x3 x4. So here you can see the variables like x1, x2, x3 and x4. So as here 4 variables are there, we get the 4 by 4 matrix. So just write the matrix here, x1, x2, x3 and x4, x1, x2, x3 and x4. x1 into x1, nothing but x1 square coefficient is 1, and x1, x2 is, so x1, x2 coefficient is not there here, so take it as 0. And then x1, x3 coefficient is also not there, then it is 0. x1, x4 is also 0, and x2 into x1, that is also 0, and x2 into x2, nothing but x2 square, coefficient is 2. So for squares we will, for diagonal elements there will be no, we should not divide it by 2, just we have tried the direct coefficient. And x2 into x3, that is 4, so 4 divided by 2. And then x2 into x4, as there is no x2 into x2 x4 coefficient, then take it as 0. And x3 into x1, nothing but x1 x3, take it as 0 as it has no term. And x3 into x2, that is 4x2 x3, that is nothing but 4 divided by 2. And x3 x3 square, x3 into x3, that is x3 square, coefficient is not there, so take it as 0. And x3 into x4, the coefficient is 1, that 1 divided by 2. And here x4 into x1, 0, x4 into x2 is also 0, and then x4 into x3, that is 1, nothing but 1 divided by 2, and x4 into x4 is also 0. So this is nothing, this is a 4 by 4 matrix. Now overall if you write 1 0 0 0 0 2 4 divided by 2 is 2 0 0 2 0 1 by 2 0 0 1 by 2 0. So this is a 4 by 4 matrix. This is our final symmetric matrix corresponding to this quadratic form. And here we see the problem. Write the quadratic form corresponding to the symmetric matrix. So the symmetric matrix is given here. We have to write the respective quadratic form. And here, so if you see here, the matrix comes as 2 minus 3 5 minus 3 2 minus 2 5 minus 2 2. So let A is equals to this matrix, and the variable matrix comes as capital X, that equals to XYZ. We know that the formula we use for quadratic form, Q is equals to X power T, T nothing but transpose of the matrix X, A into X. So transpose of the matrix nothing but this rows will be changing into columns, and that we get it as XYZ into matrix A, 2 minus 3 5 minus 3 2 minus 2 5 minus 2 2 is the matrix A, and X matrix nothing but XYZ. So this is of 3 by 3 matrix. So we have converted into X is equals to Q is equals to X transpose A into X. So here if you see, instead of solving those three matrices, it takes a lot of time. First you need to multiply this matrix with this A, and the total matrix you need to multiply with this variable matrix. So as it takes the much time in examination, so here I'll say you one trick. Just in easy way you can write, and here we know that here this is nothing but the coefficient of x square, this is a coefficient of y square, this is a coefficient of z square. So just take this diagonal here, first we know this, these are the coefficients of x square, y square and z square respectively. First write those. 2x square plus 2y square plus 2z square. So we have write 2x square, 2y square and 2z square. Then now we know that this is the coefficient of xy, this is a coefficient of xz, and this is a coefficient of xy, this is a coefficient of yz, and this is a coefficient of xz, and this is a coefficient of yz. So just write all the terms here. Here it's x, y and z, x, y and z. So just write the coefficients here as minus 3xy plus 5xz minus 3xy, from here minus 2yz, and here 5xz minus 2yz. So when you solve all this, 2x square plus 2y square plus 2z square minus 3xy comes as minus 6xy, and here 5xz plus 5xz, that comes as plus 10xz, and here minus 2yz comes as minus 4yz. So this comes as the overall quadratic form. So when you solve these when you multiply these three matrices, you will get the same quadratic form, or when you solve just by trick, then also you will get the same quadratic form here. So in this way we will find the symmetric matrix when the quadratic form is given, and we will also find the quadratic form when symmetric matrix is given.